All right, good afternoon, everybody, and welcome back to another live stream. Today is going to be the beginning of a mini series, a fun one on a framework referred to as DSP. So that is DSPy. So this is a framework that is being built out of the Stanford NLP department, and I'm actually going to take a little bit of an interesting, like an indirect approach to beginning the introduction to DSP to kind of build a frame of reference of why this is a valuable framework and why this is going to be really helpful. So today we're going to cover like a conceptual overview of what DSP is, and then in subsequent streams, I don't know if this is going to be like an additional stream or an additional 2 streams, we'll do a deeper dive on like some of the more technical implementations and like more like in a more like a specific use case. So there will be coding today for sure. It's just that we're going to be using more like boilerplate code or like simpler code that I used I used AI to help me generate. So but I did validate everything. I understand how everything works, and because that's something that's important to me. Is if I'm generating code with AI, I want to understand what it's doing under the hood. So anyway, so in the indirect approach here, so I'm going to share my screen. So as you all might recall from a stream a couple weeks ago, I did a stream on like Chat GPT for the average user, and I was demonstrating Canvas here. So this is Chat GPT Canvas, and was just demonstrating how we could create like a bulletin here. So this is like a Teacher Appreciation Week bulletin here. So now let's say that I wanted to take this, and this is a little bit lengthy, and I wanted to summarize it. So I'm going to go over into another screen here. I just copied all this. I'm going to just say summarize it. Summarize this. Summarize this. All right, I'm going to paste it in. Let the AI do its thing. Okay. So let's see what it comes up with. So what it's started to come up with here is basically the exact same version of what we gave it, but like in fewer words, more or less. But like when I look at it, so this is like we may or may not agree on like what is a good summarization here. So let's just say I don't think this is a good summarization, or at least it's not what I was looking for. So let's say make it shorter. Make it shorter. All right, and so let's see what it produces here. All right, so it's going to make it shorter, hopefully make it shorter. It's still including the emojis here. I could say, I don't really like the emojis here. It's not really useful for my purposes. So this is a much shorter version, but maybe I'm not even satisfied with this. Maybe I wanted this in a really specific structure, like let's say, I am a parent. Give me a list of actionable items I need to do. Okay. So all right. So, all right. So now this is just giving me like another flavor on this. But the thing I want to highlight here is that none of these were particularly wrong. It was just depending on like what I was particularly interested in. And so what I want to highlight here is like, let's say, I get a bunch of these kinds of different documents, and I have like, like 100 of these that I need to parse through, and I want to summarize, and I want to get it summarized in a very specific format every single time. You can see that the way that I can get to a prompt engineering template here. So we started to build like a very loose idea of a prompt engineering template. Like it was scattered across these prompts here. So we told it to make it shorter. We told it to take it from the lens of the perspective to like give a list of actionable items. And so we are starting to form our prompt template here. And so what the idea here is like, and this is where we're starting to have I hope you're starting to see the problem is that this is not a good practice in terms of scalability. So in fact, let me just show a picture to kind of demonstrate this. So you are the user here. You are manually curating your prompt engineering template as we were just showing there, and then you're getting your AI generated model outputs, and then you pass it through some sort of evaluation framework, and you basically just keep doing this manually over and over and over until you land on satisfactory results. And like that's even to say like this piece over here, the evaluation framework, like most people don't even have an evaluation framework. And when I mean evaluation framework, I mean so in a previous stream, we've done evaluations on things like RAGUS. So that RAGUS is an open source framework specifically like evaluating RAG applications. But most people's idea of a evaluation framework is what like I would just call a vibe check. It's just like, does this look well? So but like the problem here is like, even if you do like a diligent job at like trying to build a manually curated prompt engineering template like based off of our single document here, well, that's only good for one document. So, and that's a problem. That's the other problem too. If I have 100 documents here, how do I know that I'm landing on the most ideal prompt engineering template? So I hope you're so this is starting to frame up why DSP is like a valuable framework for us. So again, just want to really ground this in here. So the current state, user doing a lot of manual processing and just keep repeating this over and over and over. Like some folks out there, they're a little bit more tech savvy, so they might have a easier time, like maybe automating a little bit of this process. But like there's not really anybody that's there's not like a clean, before DSP, there's not really been a clean framework that can necessarily help this out. So let's move into introducing what DSP is then. So I'm actually going to go to their documentation out here. So DSP, this is a framework that stands for Declarative Self-Improving Python, as you can see here. And the idea here is that, as you can see by their tagline, is that instead of trying to like prompt the the language models, the LMs, to get our result, like in terms of like an ideal prompt engineering template, we're essentially treating this more like a standard machine learning project. And to be completely transparent, like I struggled a lot with trying to learn this framework, and I think it was just because like I wasn't approaching it the right way. And to be fair, like they have cleaned up their documentation quite a bit over time. But what I want to do in this stream here is kind of build more of an intuitive sense using like diagrams, and then harden it with code to kind of build this conceptual understanding, and to especially for folks who are seasoned in the data science space, I want to help to draw the juxtaposition of how DSP is sort of solving two problems here. It's ultimately solving our base problem that we were talking about, where we're trying to land on an ideally a prompt engineered template. So that's the base problem, but it's also solving this other problem of like trying to do like provide it in a syntax that is familiar, if that makes any sense. So let me go back to our pictures here. So this picture here that I'm showing represents what I perceive to be the high-level overview of DSP. So the big red box here, and the reason I chose red here is because on the documentation you can see that they've landed on red for their own logo. And so I highlight this as such is because this is like the core piece of DSP in my mind. And you can kind of see sneaking behind it here, we have our DSP signature. And again, we're just going to cover the high level pieces here. We'll cover each of these individual things in the latter sections down below, and we'll harden our intuition with code as well. But like what I want to call out here is like you basically have your like your inputs coming into the DSP module, and the DSP module is also making use of the DSP signature here, and then you're getting your outputs back. And so I do have represented off on the right here, like this DSP optimizer in the evaluation framework. Even though I have it represented on here, technically speaking, after you use after your DSP module is like optimized and good to go, then these pieces kind of fall away. So let's come down to this picture here, and let's actually focus more on the right side for now, if we can. Am I gonna be able to zoom in? I don't know if, all right, I'm gonna be able to zoom in a little bit. So let's focus on this right side here. So this is something that you might already be familiar with, and this is actually more representative like of a standard deep learning model. So the way that like when I train a standard machine learning model, whether that be a structured data model or a deep learning model, what you do is you pass in your training data set. And I don't have the validation data set represented on here. I probably should have done that, and I might go ahead and do that as well. But basically what you do is you have your, within this red box here, you have your model algorithm of parameters. So in the standard machine learning space, this might be a random forest classifier, could be an XGBoost algorithm, it could be a PyTorch model, something like that. And then you have associated to that algorithm, you have different parameters that we are wanting to tune. So the whole purpose of machine learning is being able to tune those parameters so that we can then later get an inference from that trained model. And so at the time of training, we pass in the training, and then again, I should have represented the validation data set into this optimizer. And so the optimizer is basically looking at each individual record of the training data set here and trying to determine as, okay, like what is, like based off of what I am seeing here, how should I tweak the model algorithm and parameters here? And that's why I represent this as like sort of enveloping, is that the right word? And like the blue box enveloping this red box here, where it's kind of taking it in, and actually in code, like that's actually sort of how it manifests as well, is it's taking in the model algorithm and parameters, and then like as the training job is going on, then it's tweaking those. And you can see with the over off on the right here, we have our yellow box, which represents our loss function. And so our loss function is basically this framework that helps us to determine, okay, are we on the right track necessarily here, like conceptually speaking. So when it comes to training like an LLM, like if I were to use PyTorch, for example, to train an LLM from scratch, this might be a cross entropy loss function over here. So, and then at the end of the whole model training process, then you have your resulting trained model. I wanted to, so then looking back over here at the DSP framework, you'll see like the idea is very, very similar. So the idea is like with DSP is you pass in your training data set, and then you have your optimizer looking at the training data set. So the training data set is going to be different queries, or it's going to be different examples of like inputs and outputs of what you expect to see, very much like we have with our training data set. With our training data set, so if we are training like an image classifier, we will pass in the image, and then we will pass in the ground truth or actual. So that would be like a label. So maybe the label is this image is a car, or this image is a tree. Same idea with the training data set over here. So with the training data set over here is we pass in the inputs and then the expected outputs. And so then when we pass those in at the time of training, it's or in this case in DSP's nomenclature, it's compiling. When we compile our optimizer here, then we can similarly do like an optimization of, okay, like what is going to be the best. So we'll get into this later, but like the optimizer can actually do different sorts of things, like depending on which optimizer you select. But let's say I selected one that just wanted to optimize just the prompt template by itself. And so that's CoPro. CoPro will do that. So if I land on the CoPro optimizer, it will take in our training data set and basically just keep optimizing our prompt template, our prompt engineering template to give us the best results based off of our training data set here. And then very similar to the loss function. So over here where we have the loss function of like a cross entropy loss or an RMSE if you're training it like a linear regression model, then the evaluation framework here, this might be something like a RAG-S. Or in our case, we're just going to use something super simple. And you'll see that down in code here. And so then the end result here is a trained DSP module. So I really appreciate what they did here, like trying to align the concepts. So this is very like, now that I understand this, having like a machine learning data science background, like this is perfectly clear to me. So that is a very, 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 very high level of DSP. And so now let's go into actually talking about the various components, and we'll actually enable these in the form of code. All right. And by the way, so I am taking questions on LinkedIn or YouTube. There's like a 15-second delay, just FYI, but happy to take any questions. So the first thing, I guess I should have highlighted here. So the way that DSP is doing all of its optimization naturally is it is making use of a language model. So a language model being any sort of large language model. So in our case, we're going to be using the OpenAI API just to keep things simple. You don't have to, you could use anything. I'm actually very interested in, I started doing more poking around this weekend with the MLX framework. The MLX framework is like an Apple framework to run AI models locally without being connected to the internet. So I want to get that enabled with DSP. I think that would be cool. But for now, we're going to just stick with the OpenAI API. So I actually did. So if you want to follow along with me, I started off this notebook with some minimal code just so you don't have to see me typing, but we're not really doing anything particularly fancy today. So all you need to do is, and by the way, like I do have like a notebook that it's not complete yet, but it's basically going to cover every single thing that we're covering today. And it'll like, I'll add the pictures into here as well. But it'll have like the full text and everything. But today we're just going to cover the code and talk through everything verbally. Okay. I'm getting ahead of myself. All right. So coming back up to here. So we are just setting our language model. So the way we set our language model here is, just very, very similar. How do we set like language models or APIs for like LangChain or anything else? So I'm going to be making use of GPT-4o mini. So basically you could see here that I'm passing in my API key. Ignore like what is going on here in terms of the try except stuff. That's just something that I have set because I work across weird multiple machines. But anyway, using my API key, and then I'm configuring DSP to use GPT-4o as the default language model. And that's really all to say about the language model for this one. And you will see like kind of how we will be making use, or like how DSP makes use of the language model going forward. All right, so let's move into the signature. So again, I'm gonna be skipping around back to some of these images quite a bit just to help ground things. So right now we are going to be talking about the signature, and you'll see that the signature here, it might be hard to see, is like it's sliding a little bit behind the DSP module because and that's quite intentional. And I also put like this blueprint sort of shading behind it. So let's go down here and look at what this represents. The reason I have this blueprint-like thing is because the way I like to think about the DSP signature is it's very much like a blueprint of what you were expecting to see. So you basically have three different sections here. You have your description of like what are you actually expecting to get. Now, to be clear, this is not a prompt engineering template. This is just a bare minimum, like, okay, at the end of this thing, I want summarizations. Because remember, like if we were to like back with our example over here, our teacher appreciation summarization example, we're not trying to get a perfect prompt engineering template here, because we're just going to feed in a bunch of, like, imagine we had like 100 of these. We're just going to feed in a bunch of these with examples of how we want to summarize and let DSP figure that out for us. And so in the description here, we'd keep that rather minimal, and we just say our doctrine would just be here like summarization, or maybe even nothing. Maybe you put nothing in here. And then inputs and output fields. So these are interesting, where like they're very similar in how they operate. It's essentially where you define what you are going to be giving to the language model and what you expect to receive back out. And this can actually be quite structured. So let's say you want to return some sort of integer value, then you can do that as such with the output field here. All right, so let's go ahead and actually jump into some code here and demonstrate how to create a signature. Now, actually, there's two ways to create a signature. There is the inline way, and then there's the class way. I am not wild about the inline way. I appreciate the inline way. It is, I just see problems with my concern with it is like syntax errors. Like, well, you'll see here in a second, but so let's actually cover the inline way. And so what the inline way is, and actually we're going to be making use of a built-in module. So DSP actually provides a number of these various built-in modules. So we're actually going to be making use of a built-in one right now, but later on in the stream, we will be demonstrating how to create a custom one of these. So we're just going to be using the standard one. It's called predict. And just like the name implies, all it's doing is just taking our input and then like producing an output. So we are gonna do like a sentiment classification thing. So we are gonna feed DSP, or we're gonna create an inline signature that defines saying, okay, we're gonna pass in a sentence and we want a return Boolean value that represents true if the sentence is like positive, or if the sentence is negative, then we want it to be false. So let's go ahead and set some examples. So I'm going to set positive sentence equals I am very happy with the results of this project. All right, so that's a positive sentence. Let's do it. All right. So, all right. I'm just going to do the autofill because I'm lazy. All right. So I'm going to call what I'm going to be doing here again, we're going to be making use of the DSP module, like predict module. And then, so I'm going to call this DSP sentiment classification equals, let me make this bigger for y'all. Hold on. Boom. All right, just to make it extra bigger. Wow. All right, DSP, and I'm going to call this DSP.predict. All right, and then so here is where we have our inline, what do you call it? Signature. Oh my gosh, I'm stumbling over my words. So I'm going to say sentence. So we're going to be passing in our sentence. And then we to get our outputs here, then we do this little dash greater than sign, so to like kind of represent an arrow. And then we're going to say we want the sentiment, and then we want that to be a Boolean. Okay, so here's why this makes me uncomfortable, and you'll see why here in a minute. But like, because we're representing this as a string, Python represents that or recognizes that as a string. So if you were trying to, like, let's say I accidentally said I meant bool, but I accidentally typed bowl. Well, Python's not trying to correct me on that right now because it's not designed to be able to look for that sort of thing in strings. But anyway, so let's say I wanted to actually make use of this. So I'm gonna just print out type up. Oh my gosh, copy and paste some print strings. Oh my gosh, stumbling over my words today. All right, so let's go ahead and invoke that. All right, so again, this is we already set the configuration model or the language model up here. We configured that with O4 Mini just as a reminder. So you can see as we pass in each of these into our predict module with the inline signature, then we are getting the Boolean values that we would expect back. So can recognize these appropriately. So that is the inline way. So let's say we wanted to use the class-based way, and the class-based way is also more preferable if you want to make things more complex. So let's actually make a more complex version of what we did here. Let's give ourselves some more room in terms of cells, and let me look at my notes here. All right, so let's say I wanted to use the class-based version. So I'm going to say a class. I'm going to call this class text analysis signature DSP. And so we're going to inherit from DSP signature. Sometimes GitHub Copilot can be a little bit eager. So, all right. So recall here again. So we have essentially three components or three sections that comprise our signature. We have our doc string or our description, which is represented by this doc string at the top of the class. We have our input fields and our output fields. So you didn't see these with the inline signature. So this is basically an input field and this is an output field. So behind the scenes, if you use an inline signature, then DSP recognizes that and kind of restructures it into this format for you. So we're going to make that a little bit more explicit here with our code here. So first thing first, let's put our signature. So we're going to say analyze text for sentiment, main topic, and formality level. Okay, so that's what we generally expect to see. So you can see we're giving it a clear goal without telling it necessarily how to get to that goal. How to get to that goal, that would be doing like the full prompt engineering template and going back to our whole manual process, basically doing this thing here, which is what we're trying to avoid with the whole DSP framework. Okay, so let's come back down here. All right, so I'm going to setting the input field, So I'm actually going to take in two input fields. The second one's going to be nonsensical. It's just there to demonstrate, so like that you can take in multiple. So I'm going to say the first one is text dsp.input field description equals the text to be analyzed. It's going, and then now for maybe I don't know if this is just a me thing. Now I do have to set like default values for each of these things whenever we do the optimization. That might just be a me issue. But like whenever I created my custom module, I did have to set this. If you used like some of the other like built-in DSP modules, you don't have to set that. So might just be a me issue. All right, anyway, so the next one I'm going to set is language. Now, this is the one that's kind of nonsensical. So DSP.input field description equals the language of the text, default equals English. Now, the reason I say it's kind of nonsensical is because, like, you'll see in a little bit that all of my examples are all going to be English. So it's just to demonstrate here, though, that if you want to use multiple inputs, you can. All right, so that's the input field. So I'm actually going to extrapolate on the output field. So in the output fields above, we just had the sentiment of getting the Boolean. So let's do a couple more. So setting the output fields. So I'm actually going to do the sentiment. So sentiment equals DSP dot output field description equals the sentiment of the text, positive, negative, or neutral. My face is getting in the way. Let me get my face out of the way. Sorry. All right. Positive, negative, neutral. All right. Default is going to be an empty string. Default empty string. Now, I want to call out something here. You might have noticed that I put 3 very specific category types. That's actually quite intentional, because what you'll notice here is that as we start to produce outputs, we are going to consistently see that our output should be one of these 3 types. Now, I could actually harden this a little bit better by saying, because I noted that you can actually put like very specific data types here. That'd probably be a better idea. But this actually in my practice actually worked quite well additionally. But just note that this is probably not the ideal way of doing things. So that's sentiment. What else do we want to get? Let's get the topic. Let's get the topic of the text. So topic equals DSP output the main topic of the text. All right, that's good enough. Formality, let's see how formal that is. The formality level of text. So I'm going to do that same idea here. I'm going to sneak in 3 categories. I'm going to say formal, informal, neutral. Okay, so those are the 3 categories I want to see back. Formality, and then let's get word count. So this is where we're going to demonstrate like where we can actually get an integer value to return back. Okay. Type. Yeah, I want to set my type here. So type equals, and so that we're actually going to explicitly type there. Okay, so that's our custom signature. So you could see here, I want to just again compare the two. So as a reminder, this was our inline version of the signature, and this works perfectly well. So I don't want to rag on that too much. And this might be good if you're just trying to do something, some simpler quick testing. I prefer this way, just because it is a little bit more rigorous. It does allow more flexibility, and then it does catch for the syntax error. So you'll note here that I put int. So I noted here, like if I put if I put BOL instead of the correct BOOL, Python won't catch that. However, if I come down here and if I put an A in there, then it's gonna have a little squiggly line being like, okay, Python's recognizing what the heck is this. So that's just personal preference. But I think once you see the syntax is actually relatively simple as well. All right, so that is our signature. Now let me show you how you can go ahead and make use of the signature just within so we made use of this predict module up here. And again, we will talk more about modules here in just a minute, but I want to show you how we can already make use of the signature, even just directly with the DSP signature, or with the DSP predict module. So I'm going to call this DSP text analyzer equals DSP.predict. All right, so we are passing in our signature that we are just created up here into the analyzer. And then let's go ahead. I have a couple of examples here. I'm just getting a little bit lazy. So I'm just looking at my other screen right now. I'm going to go ahead, just for time's sake. I didn't get my examples. Just for time's sake, because what time is it? Oh, it's already 3:30, and it's sunny out, and I want to go enjoy the weather. So all right. So let's step through my code here. Might help if I had the ordering of these code of the syntax right. Okay, so as we already did, we already created a signature. You see how we have passed the signature into the default, one of the default DSP modules called predict. And now we have a couple of different general examples here. So we have like a business email and a casual message. And then we just have some extra code down here. Don't worry about this. This is just some special printing stuff. So let's go ahead and run this and see what happens. All right, so and let's remind ourselves really quick what these are. So this just says, "Dear Mr. Johnson, I'm writing up to follow up on our meeting last week regarding the recorded financial report. The results exceeded our expectations." So this is, I would say, professional. I would say positive. Professional, positive. What else do we have in here? The topic would be something business related or financial related, and then word count. I'm not even gonna bother counting those words. And then you get your casual message. So, hey, can't wait to see you this weekend. The party's gonna be awesome. All right, so then we have. So I'm gonna say this is definitely going to be positive. It's gonna be informal. It's going to be the topic. I just realized that I don't have this in the right spot. Glad I got that. Yeah, I should have put that there. Oops. All right, let me check that again. All right, so that is probably not, that probably didn't even run correctly then. Okay, so, all right, let me double check that one more time. All right, so casual messages, that's right. So sentiment is going to be positive. Topic is going to be, I don't know, invitation, I guess. Formality is going to be informal, and then number of words is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I might have miscounted there. Okay, I counted 15. All right, so it did the results of the model. It did note it correctly as positive. Both of those were positive. This one it noted as a quarterly financial report. Fair enough. Now, if I wanted to be more specific, like let's say if I was passing in a number of different documents, but it was like just of 5 different category types, then I would want to pass that in as well. And then that'll be more. So we use very simple examples here. We're just using simple strings. You will see here in a minute how we're actually going to be using the expected syntax of how to actually use the optimizer here in just a minute. But anyway, so all right, so we have our topic is correct, our formality is correct. Word count, I don't know if I counted that correctly. Let me count that again. How many did that say? It said 15. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to call that a hallucination. Or maybe it was counting tokens. I don't know. Again, we are using 4.0 mini here. But I guess that's the other thing to highlight here is that the nice thing about this framework is if you wanted to just, because you will get different results depending on the language model you use. So if you're using 4.0, for example, or I'm sorry, 4.0 mini, which is what we're using right now, which is the lowest tier version of that OpenAI offers in their API right now versus O1 Pro, which is O1, which is in the API. Obviously O1 is going to do a lot better in terms of performance because it's a much bigger model, it's a reasoning model, et cetera, et cetera, et cetera. So you can actually, and the great thing about this framework is, okay, well, let's say I just want, you can even see I kind of demonstrated here already. If I wanted to test out 4.0, well, then all I have to do is then just take my 4.0 here and then swap out and do a different configuration here. And so, okay, so that is oh, wow. I apparently, oh no, we've not even gotten that far yet. Okay. I'm not skipping ahead. All right. So so that is just demonstrating the signature with a base level module. So if you want to see what other modules are offered out here, so I would just go out to the DSP tutorial, or I'm sorry, their documentation out here. And then if you go into get started, is it get started? Or no, I'm sorry, learn DSP. You can see all the different sorts of concepts that we're covering today are very much cataloged over here. So if we wanted to come look at the different modules that are offered here, you can see that they offer a chain of thought one, and that there's a React one, and React is the agentic framework sort of idea. Oh, here we go. Here are the other ones that are offered. But let's say none of these are necessarily to your satisfaction. We can create our own. So this is where things start to get very PyTorchy, or I guess it's not too fair to say PyTorch, but very deep learning framework E. So again, let's remind ourselves that this framework is very much designed to be like a mirror of the standard traditional machine learning process. So, and I'm going to specifically focus on PyTorch because that's the deep learning framework I'm the most familiar with, and you'll see that the syntax actually, in my mind, actually mirrors that of PyTorch the most. It might mirror that of JAX as well. I haven't looked at JAX, or it's been a long time since I've touched PyTorch, or I'm sorry, not PyTorch, TensorFlow. But anyway, so again, let's actually just jump into building our module now. So let's think about what our module is actually doing. And this actually might be too big. I might need to zoom out. Okay, there we go. So the module essentially, the way I understand it is, there's two sections. Now you can add different functions as well, but you essentially have you have your tunable parameters. So these are the things that you're trying to optimize. So in our case, we are these are just different examples that I put in here. You might not have all of these in yours. So in our example above, we are trying to optimize our signature. So our signature, again, is basically represents our prompt engineering template, except we are not trying to do the prompt engineering template or the prompt engineering ourselves. We're trying to make use of DSP to basically optimize this whole thing to get an ideal thing out. So that's what I mean when I refer to as tunable parameters, because when we get to the next section on the actual optimization, then you'll see how these different tunable parameters actually get tuned. And then we have our program flow. So within the default DSP modules, they already have these built in by default. But in our custom instance, you'll see here how we're actually going to define these ourselves. So basically, you can see how I have kind of illustrated this by steps. It's basically you do this, and then you return the result. And so you can see here that the tunable parameters actually manifest in this def init section, and then the program flow actually manifests in this def forward section. And again, I want to highlight this because let's actually go to the PyTorch website over here. So this is the PyTorch website, and you can see here this is a PyTorch, a custom PyTorch model that this person is building, I think. I just grabbed something that looked kind of like what I was like looked like it was correct. But basically, this is super simple. You can see here within the init function that they are defining a couple parameters that they will eventually tune, and then you can see here within the forward module or forward function here that they're defining this function of what they actually expect, how this program should be invoked whenever it's created. And so the syntax is going to be very, very similar, again, back to DSP here. So that's what I want to represent here with this over here. But let's actually manifest this in code now. So let me scroll down on my notes. So we're going to create a simple, very simple module. Now it's kind of honestly, this is going to be kind of redundant, redundant in the sense that well, you'll see why. So what I'm going to do here is I'm going to say class text analysis module DSP module. Okay, so I'm going to define my init. So I'm going to do that self, and then I'm going to do the super init. This is just kind of standard Python stuff whenever you're doing inheritance from another class. And again, we're inheriting from the DSP module because we are creating our own custom one. Now I'm going to define just our one predictor, or the one parameter that we want to alter for our specific case. So I'm going to say self.predictor equals DSP.predict. Okay, so as you can see, this is very much similar to what we did above. Actually, that's the exact same. So that's why I say it's redundant in our case. So just to mention, today is just, again, a familiar, an introduction to the concepts. We'll get into something that's more meaningful in a future stream. So this is, if you're wondering, does this seem like overkill? Yes, absolutely it is. I would just, for this specific case, I would just use DSP predict. But I just want to highlight how you would do this if you did want to create your own custom module. All right. So we're going to do self text. So we're going to take in, and then we're going to have the default there, return self.predictor, text equals text, language equals language. All right, and that's it. So that is how we create our own custom module. Now let's say that we actually want to make use of it. So I'm actually going to just copy and paste all this code here, because it's going to be the exact same thing here. All right. The only difference this time is that instead of this here, now we're going to make use of this. So I'm going to say goodbye to you and hello to you. And then when I run that, now it looks like nothing happened, but it did. It just, because it used the different thing here. It just, again, it was kind of, it emulated the exact same functionality, which is why the end result was the exact same. I think it was the exact same. Yeah. Quarterly financial report. In fact, I was going to test with another model, but I don't think I'm going to. The stream's already starting to run longer than I was expecting. So let's move on. All right. So we've created our module. So all right. So let's recap. Where are we at? All right, let's come back to our original framework here. So we talked about the DSP signature. We just built our own DSP module and demonstrated how the signature kind of makes use of that. So now we are going to move into optimization. So optimization, this is the idea, again, here in the traditional AI space, you would think this as like the model training period here. In this particular case, there is no model that's being trained. I guess one thing I should have highlighted as well, for my tutorials that I'm doing for this series, I am specifically focused on prompt tuning or prompt and template tuning. I believe that DSP can be used for fine tuning as well. Which is something that I am interested in exploring. It's just that for the purposes of this series, I am not looking into that. Just not at the moment. But just to make you aware, like that is another thing you can do with DSP. But anyway, so let's we already kind of gave a rundown of like what this is doing. But just to I guess we're gonna give another round because I really want to highlight the intuition here, because I think I'm a big intuition guy. I think intuition is super important when you're trying to understand these things. All right, so again, we are gonna be giving a bunch of different examples of what we're expecting to see, and then we are using our optimizer here. Then we are in our evaluation framework. We are going to pass all those examples in to hopefully get an optimized DSP signature. And again, what are we optimizing with the DSP? I'm sorry, not DSP signature, DSP module. With what we are optimizing with that, we are trying to get an optimized signature, and we have instantiated that as a tunable parameter here within the DSP module. All right, so let's start to write out some code. Well, actually, you know what? Let's talk about the optimizers first, because the DSP offers a number of optimizers. Now, if anybody on the DSP group is watching this, the one thing that I would sincerely appreciate is better documentation around here, because the only this documentation is rather limited, and I'm not really sure how to interact with this from here. I've had to dig into the source code to try to understand like some of the like options and stuff and what I can do. So that's why there will be future streams, because I'm still not even comfortable myself with like the deep ins and outs of what you can do with this. So I would appreciate some, just some more thorough documentation here. But anyway, so all right, so what are so there DSP offers a number of different optimizers. So there is automatic few shot learning. So few shot, if you are not familiar with this idea, is basically whenever you're doing your prompt engineering template, you would also provide a number of different examples along with that prompt engineering template on what you would expect to see. So that's why we would call that few shot. So this is basically whenever you are passing in your examples, it would create the different sorts of few shot learning examples that you could provide as well. And then there's actually one in here. So this next section down here is the optimization tuning. And so we're actually going to be making use of MI Pro V2 down here, but MI Pro V2 will actually optimize both the few shot examples and the instructions. So if you are specifically interested in like getting this sort of thing right, so where we were talking about over here, where we were trying to get like the ideal of like, I'm a parent, give me a list of actionable item things to do, like and you were only concerned about that, then I would say that CoPro is probably your thing. So CoPro and MI Pro V2 are the two that I am most interested in. And in future streams, we will cover more in depth on what those do. just because I'm not prepared to talk about those today. We will code with them though here in a minute. But I just want to highlight that there are a number of different modules you can use. Now let's talk a little bit about the evaluation framework. So we have the evaluation framework over here. So DSP, this is not really their focus. They do offer a little bit in terms of here, but this is where I would, I think if they were here on the stream, I would think it would say you would bring over whatever is the most effective and meaningful for you. So like, let's say that we were trying to build a DSP optimizer for like a RAG system. I would actually say the evaluation framework should be RAG-S. So again, like I said, DSP actually does have a handful of like things that you can use for evaluation for like directly baked in. I'm actually going to keep things extremely simple. So with our evaluation framework is just going to be this function called here. I'm going to call this def text metric. So it's going to take an example, and it's going to take in a prediction. Okay. And then score is going to be, we're going to initialize it to 0. And then we're basically going to say, okay, if, I'm just going to copy and paste this because I'm getting lazy again. Lazy and tired. I want to go outside, man. What is the temperature? 59? And I'm down. Okay, if you're wondering why I'm like bundled up, so I'm in my basement, and my basement is always like 2 or 3 months behind the rest of the season. So like when it's like December weather out, my basement thinks it's still like October. So even though it's March now, my basement thinks it's January. And so it's freezing in my office right now. And that's why I'm bundled up. Okay, back to the stream. What was I talking about? All right, so here's our text metric. So basically what we're doing here is, all right, we have our different prediction things that we're getting out of here. And we're basically saying, okay, if the prediction matches the sentiment, like example, so like we are going to pass in you'll see the examples here in a second. This is very much, again, a machine learning kind of concept where we're comparing the prediction, which is the inference, to the example, which is the ground truth or actual. And like basically I'm just saying, okay, if you have each of these things or they match, then I'm going to give you a hard plus 0.33. And so obviously if you get all of these, then you get a max score of 1.0. Now this is a super, super kludgy, pretty not great way of doing things, but or like having an evaluation framework. Again, this is where like if you were doing something more robust, you might want to use something like RAG-S instead. But for our purposes for today, we're keeping things super simple. So this is our quote unquote right here evaluation framework. So let's actually go ahead and I was talking about the different examples. So I just used ChatGPT to help me produce a number of different examples. So I'm just going to copy and paste these in. And today we are not going to really talk about the syntax so much here. I just want to just kind of give you a very light introduction. Okay, I don't think I got I'm missing a right bracket there. Okay, so you can see here, so this is like a DSP object where we are passing in our different examples, and this would be like our ground truth result. So you could see here, I absolutely love this product. It's amazing. And then, so our ground truth result would be that it's positive. Our topic is product review. It's informal, and it's got an 8-word count. And so this is going to represent our training data set, if you will, when we run when we compile the optimizer here in the next step. So probably in the next stream, what we'll do is we'll actually cover like the syntax of, let's say I got my text in a bunch of .txt files. What is the most optimal way to get into this structure? Like we'll probably cover that as maybe like the next stream, I think. Anyway, so we set all of our examples there. So this is, by the way, a list. I don't know if that was clear. So this is just a list of examples. Okay, so let's actually go ahead and instantiate our optimizer. So we are going to use, here I'm going to say optimizer equals the MIPro v2 that I was just showing off there. So that is intended to optimize our prompts, our DSP module signature, which again, the signature is more or less like the prompt template. So MIPro v2. So our metric is going to be our text metric. And then I'm going to set this auto to equal light. Okay, now I can't remember exactly what this is exactly what like I was kind of talking about in terms of like I would appreciate better documentation. I can't remember exactly what light is doing. I believe here, let me look at the documentation. Oh, I guess that's another thing to call out here. It looks like whenever DSP got started, they originally called these optimizers as teleprompters, and so if you look at the source code, you like it's still labeled as such as teleprompters, but like they have since started adopting the optimizer nomenclature. And that makes sense, just given that they're trying to mirror like the other deep learning frameworks like PyTorch. But yeah, so you can see. Okay, so here's the like what those settings here. So it looks like it does the different trials and such. So I'm just gonna keep it to light just to keep things quick, because even as you'll see here, like this is still gonna take a minute or so to run. And so now what I'm going to do here is, so again, recall here up here. In our previous section when we created our DSP module, like now we have instantiated it as this text analyzer object. All right, so what I'm going to do is I'm going to bring it on down here, and I'm going to say optimized DSP text analyzer equals optimizer dot optimize. All right, so I'm going to do that. I'm going to do a deep copy, just so I'm not altering the original variable just in case. I don't think it would anyway, but not a bad practice. I'm going to say my train set is going to be the training examples. So that's all this stuff that we instantiated above here. Okay. I'm going to put max bootstrapped example or demos equals 5. Or yeah, I'm gonna do max labeled demos equals 1. And then now this next one, if you don't have this set to false, it just is really it runs really goofily in the like Jupyter notebook. In fact, I'm gonna demonstrate it. So it requires like I appreciate what it's trying to do here, but it's kind of just an annoyance in a Jupyter notebook, especially in the in VS Code. All right, so I'm going to say equals true. Now I'm going to set this to false here in a minute, but I want to show what happens. All right, so when I run this, and my real v2 has no optimize, did I optimizer.compile? Oh, I didn't type that right. So this is the problem with using tools like GitHub Copilot is, like, especially with newer frameworks, is that it just hallucinates things that it just sounds right, but it's not. So that was one of those gotchas there. All right, so here's the goofy thing I'm talking about here. Now, if you read through this, if you skip all the way to the end, you'll actually notice, do you wish to continue? And here's the problem. Like, even if I press enter, so I'm going to press enter here. In fact, I'm going to prove it to you. I'm going to grab my keyboard. That's my enter key. I'm going to press it right there, and it just aborted it. So that's the goofy gotcha of doing it here. And so well, actually, let me run it again, because what I do appreciate what it was trying to do here is it was just trying to give like an estimate on like how long it would take some of these things to process, and how many batches and whatever. Now it's kind of hard to read here. I think in a different context, it would be easier to read. But anyway. So I'm going to just get out of there. So I'm going to set this to false. So that's how you just suppress it to go away and skip past that little page there. So let's go ahead and run it and see what happens. All right, like I said, so this is going to take a minute because it's running. It is actually invoking. I can't keep going back to like this picture here enough. What we're doing is we're passing in all those examples right now, and it is using the GPT-4o Mini API to basically just continually hit our evaluation framework, which is our goofy little Python function that we created, and it'll hopefully produce an optimized signature for us here in the end. All right, so it's going to take a minute because it's going to want to do this right. Oh, I guess that's one thing I do want to call out is I quickly started to run into rate limiting errors here. So if you're not familiar, what is a rate limiting error here? Or what is a rate limiting error? This is this idea where basically OpenAI, or not just OpenAI, but no model provider wants you spamming their API and just basically trying to like kill your, like they're trying to prevent DDoS kind of things and things along those lines. And so they rate limit you, and especially if like you're a low user like me. So in terms of like my personal OpenAI API key, like I'm like one of the lower tiers, and so my rate limit is low. And so when I ran this cell here, like back to back a couple of times, I very quickly started to run into rate limiting errors. Now, okay, so let's highlight what happened here. So it went through a number of different trials. Now I want to go through like the intuition of what is going on under the hood in the future stream, but I just want to kind of highlight here like some of the logs. So at the very beginning with our as it's starting to analyze things, we see that our first trial here just it produces a score of 71. And then I don't know where it's necessarily getting these scores from. But as you can see, as time progresses, or as each of these trials progress, that we continue to get different sorts of results. And so that we can finally get the best identified program with the result here. So let's go ahead and like actually figure out or look at like what's going on behind the scenes there. All right. So let's go to, all right, so this is our optimized DSP analyzer. So I'm going to look at the candidate program. So these are these are going to represent each of the different things it tried to do. And they're all going to look fairly similar. So it's going to be kind of hard to detect what it did differently, but it should be like, let's try to see where some of these went differently. All right, so I'm going to compare like this point, all right, this 0.675 to the 0.6262, like where was it different at? Okay, so you can see where it actually took a different approach of where it tried this whole thing of you are a text analysis expert versus just not doing that. So you can see all the different trials. Now the funny thing, this is probably just because we're using so little data and such a simple example. I believe the final output was just like basically our raw DSP signature. In fact, let me go ahead and save that out just to demonstrate that. So I'm going to say optimized dot save, and then I'm going to do that. I'm going to give it dot JSON, not sonj, JSON. All right, there we go. So, all right, so I've saved it out, and you can see here that it basically did not change anything. In fact, let me see if I can split that off over here. All right, so this is our stream. All right, where is our signature that we defined? All right, our signature, there it is. All right, so the text to be analyzed, language of the text, sentiment of the text, the main topic of the text, formality of the text. Yeah, so it didn't change anything. It didn't change anything at all. I mean, it maybe added, well, I don't know if it added these prefixes or not. And that's okay, because what it's basically proving to us is that for our sample set here, the simplest path forward was the most optimal. But that's why I'm kind of glad that we were able to see the candidate program still, just to really highlight that, oh yeah, something did happen. Because the first time I ran this, I got the same results. And so I was wondering, oh, did something not work? But it did. And so I'm glad we were able to kind of still highlight that. Okay. We are coming up on the end here. All right, let me read my notes. I think that is everything that I wanted to cover for today. All right, so I hope that gives you a kind of a high-level understanding of how DSP works. Like I said, it's when you start to see it in a visual form, and like I'm a visual guy, like it's actually quite intuitive, and I really like as well like how they really drew this juxtaposition between like standard machine learning for folks like myself who do have the experience over on this right hand side over here. All right, so that covers it for today's stream. Like I said, in the future streams, I don't know if it's the future of the series is going to be 1 or 2 more, could be 3 more series or entries, but I want to cover. Because we just kind of covered a very simple example today. I want to do like more of a fully fledged example, specifically like I would like to do a RAG example for sure, and maybe a summarization example, like a better version of like than what we were doing here today, though. And so, yeah, I think that's all I want to cover for today. So I hope you appreciated this stream, and I will see you in the next one. Have a good rest of your weekend. Bye.